All right, now we're going to work with some inverse values. The first thing I would do if you're struggling with these is draw yourself a diagram of where you're looking for arctangent, arccosine, and arcsine. So for sine and for tangent, your angle values, and all of these answers are going to be angles, your angle values are restricted to the first quadrant and the fourth quadrant. And in the first quadrant, you're dealing with only positive angles. So your angle possibilities in the first quadrant are pi over 6, pi over 4, pi over 3, and pi over 2. In the fourth quadrant, you're dealing with those negative angle values. So you're going 0 to negative pi over 2, and your possibilities are negative pi over 6, negative pi over 4, and negative pi over 3. So if you see arcsine, or sine to the negative 1, and arctangent, or tangent to the negative 1, the angles that I've drawn here are your only possibilities. Those are your only solutions. Cosine, arccosine, or cosine inverse, you're only looking in quadrants 1 and 2. And that's a little more intuitive. Just don't use the third and fourth quadrant values. So our first is a cosine problem. Cosine of negative radical 2 over 2. So cosine is positive in the first quadrant and negative in the second quadrant. So the second quadrant is what I need. Our fourth in the second quadrant is 3 pi over 4. And if it would help you when you're taking the test, go through and do all the cosines first. And then you can switch modes for tangent and sine. So the other cosine that I see is here, arccosine of radical 3 over 2. Cosine is radical 3 over 2 at pi over 6. Oh, and this problem order is from test C. So if you're doing test D, you should have the same ratios, I believe, just in a different order. I don't see any other cosines, but I do see arcsecant. And if I'm dealing with arcsecant or secant inverse, that's the same as flipping that fraction for cosine. So here, where's cosine negative 1/2? Cosine is negative 1/2 at a pi over 3. And it's the pi over 3 that's in the second quadrant, which is 2 pi over 3. So there are all of your cosines dealt with. Let's go through and do all our sines next. I'm just picking whatever order kind of works for me. I had my cosine picture there. So again, sine is positive in quadrant 1 and negative in quadrant 4. So if I look for some sine values, the first one I see is number 4 here. Sine is 0 at 0. Sine is negative radical 2 over 2 at a fourth. And since I'm doing arcsine, I know I'm restricted just to the fourth quadrant. So my fourth in the fourth quadrant is negative pi over 4. And that's all my sines, but I do have a cosecant. If cosecant is 1, then sine is 1. Again, just like we did with the secant, you just flip that fraction. So that means sine inverse of 1 is the same thing that you're solving for. And sine is 1 at pi over 2. And that is in the domain of arcsine. All right, and now our middle column here, at least on test C, are tangents. So let's work with our tangents. Tangent is 1 at my fourths. And negative 1, again, I'm referring to the same picture here. We're looking in the first quadrant for positives and the fourth quadrant for negatives. So the fourth that I have in the fourth quadrant is negative pi over 4. Tangent is radical 3 at pi over 3. Again, I'm not looking for the other place that tangent would be positive when I'm working with arctangent. I'm only looking in quadrants 1 and 4. This one's a little tricky. Cotangent is negative radical 3. So that means tan inverse of 1 over negative radical 3 is what we're looking for, which means we need to rationalize there. So what really turns up on our unit circle is negative radical 3 over 3. And that happens, remember we use our little trick, 3 plus 3 is 6. So that happens at negative pi over 6. Pi over 6 because of our radical 3 over 3. Negative since we're in the fourth quadrant. And for arctan, that's where we're negative. So our value's right there. I hope that you find these diagrams here helpful. I think cosine is a lot more intuitive than sine and tangent. And the second time through will be better.